So let's try to take a look at this problem and find a solution. In a 67.0 gram aqueous solution of methanol, the mole fraction of methanol is given 0.110, or what is the mass of each component. So we begin thinking about the components of this solution. Obviously, methanol is one of the components, and the second component is water. So we begin by writing what the problem gave us. Number one, the mass of the whole solution is 67 grams. But we have to open this up because the mass of the solution actually is the combination of the mass of methanol and mass of water. So we substitute this idea that the mass of the solution is the combination of the masses. The second piece of information that we have received is that the mole fraction of methanol is 0.110. We once again open up the information. We have to remember that mole fraction is a fraction of number of moles. So if the mole fraction of methanol has been given to us, we have number of moles of methanol on top divided by the total number of moles, which is the sum of the number of moles of methanol and water, since these are the two components in the mixture. We have to find now something that links the idea in green with the idea in blue. We need a link between mass and moles. The link comes from molar mass. So what I'm going to do next is to substitute number of moles by the ratio of mass over molar mass. So where I see number of moles of water, I'm going to substitute by mass of water over molar mass of water. The mass of water is one of the things that we have to find in this problem, and we don't have. But we do have the molar mass of water. All we need to do is look at the periodic table to gather this information. I have purposefully removed the units of molar mass, which are grams per mole, because I'm going to do a lot of substitutions from here on, and I don't want the units to get in the way. The first substitution that I will do is to take the number of moles of water and substitute by the number of moles of water in the mole fraction equation. So the first substitution looks like this. I took the number of moles of water and substituted by mass of water over molar mass of water. The next substitution will be on number of moles of methanol. Similar to what was done with water, the number of moles of methanol is the mass of methanol divided by the molar mass of methanol. We substitute the numerator and part of the denominator. So after the substitution, we now have an equation that contains the mass of methanol and the mass of water, the two variables that we are trying to figure out. So we need a connection now between the mass of methanol and the mass of water. And this connection is found in the mass of the solution. Remembering that the mass of the solution is the combination of the masses of methanol and the mass of water. We can then write that the mass of water from this equation is 67 grams minus the mass of methanol. And the mass of water will be substituted in the mole fraction equation that we have. We are inserting the substitution right here in blue. The mass of water is 67 grams minus the mass of methanol. I omitted the grams so it doesn't get more confusing than already is. Upon substituting, we now have only one variable, which is mass of methanol. Everything else is a number. Of course, this requires a little bit of rearranging to be able to get to the final answer. So the first thing that we have to do in this problem is to observe these two denominators here. So we basically have a sum of fractions. We have to make sure that the two denominators are brought to the same common multiple. To be able to do that, I have to multiply the first fraction by 18.02. And I have to multiply the second fraction by 32.05. So this becomes mass of methanol over 32.05, which we have in the numerator. So I'm repeating it. Divided by the first fraction, 18.02, mass of methanol plus 32.05, multiply in the parentheses of 67 minus mass of methanol. And this is all dividing, or divided by, the multiplication of those two numbers in the denominator. 32.05 times 18.02. At this point in the algebraic manipulation, we have to recognize that we have a division of fractions. A over B divided by C over D. And every time we have a division of fractions, we can simplify this by maintaining the first fraction in the numerator, A over B, and multiplying by the inverse of the numerator. And that's exactly what I'm going to do. If I look at the green line represents this big line here in pink. So I have a fraction on top that I'm going to keep exactly as it is. And I have a fraction on the bottom, below the green line, that I'm going to flip. So upon dividing the two fractions, which turns into a multiplication of the first fraction by the inverse of the other, we notice that the number 32.05 actually cancels out, which is always welcome when we can eliminate something, right, to make the equation simpler. And so what we end up in the denominator is the leftover 18.02 in pink multiplying the mass of methanol in yellow. And in the denominator, we have what has been left over. So It's still a long equation, but it is a more manageable equation than what we had before. The thought process now is cross-multiplying the denominator by 0.110. So this is the numerator that we kept, equal to the cross multiplication. And the next step is to distribute this 0.110 to both terms of the addition. So in green, we see the result of this distribution. So the next step is distribute this number into the two terms of the subtraction. We are getting to the end of this problem, and we notice that we now have an independent term, meaning a term without a variable. And we have mass of methanol here, mass of methanol here, and mass of methanol over here. So we now have to accommodate this equation in a way where the independent term is on one side of the equation, and all the terms that contain the mass of methanol are going to be on the other side of the equation. I am keeping the independent term on the right side of the equation, and every term that contains the mass of methanol is going to go to the left side. Since all of these terms are mass of methanol, I am going to consolidate the numbers in parentheses. Once we have our equation a little bit more organized with all the terms in mass of methanol consolidated, we can simply subtract and add as appears in the parentheses. And this number becomes 19.5633. And so we are going to basically have a number multiplying our x, if you will, mass of methanol is what we're after, equals to this independent number over here. So we find the mass of methanol as simply being 236.2085 divided by 19.5633. Therefore, the mass of methanol is 12.0741 grams. Recall that the mass of the solution is 67 grams, so the whole thing has a mass of 67 grams. So the mass of water is the whole thing minus the 12.0741 grams. The mass of water is therefore 54.926 grams. Now, these results for mass of methanol and mass of water can be validated. In other words, we can check if these results are correct. We can check by finding the number of moles of methanol, which is the mass of methanol that we calculated over the molar mass of methanol. We can find the same thing for water. The number of moles of water is the mass of water over the molar mass of water. With the number of moles of methanol in water, we can calculate mole fraction of methanol by substituting the number of moles into the mole fraction for the methanol. And we obtain the 0.110 that was initially given in the problem, validating, therefore, our solution. Thanks for watching.